Hi, my name is David Flores, and I'm a senior automation consultant at Network Code. In this session, I'm going to talk about Molecule for testing network automation Ansible projects. A little bit about me. I'm a network automation engineer that is focused on software development and automation practices for the network infrastructure. I'm experienced in the service provider networks and big data center fabrics. Here are a couple of links if you want to follow me. Feel free to do so. Now, about this talk. This is about using Molecule for testing your Ansible projects in a network automation context. I'm going to talk about the importance of testing and the common challenges that you face in Ansible projects. Going to go through Molecule, what it is, how it works, and its main features. And I'm going to close with an Ansible project testing on a specific scenario. It's called mock. You're going to see it a little bit later. All the code in the playbooks of this demo can be accessed on this GitHub repo. And so if you want to follow along or execute it yourself, feel free to do so. Now, what are the challenges for network automation? You can see that I omitted the importance of testing part in the title. Mainly because in this day and age, it's crucial for you to test your Ansible projects, especially if they're going to interact with your network infrastructure. Now, the main challenge is that you need network devices to test your Ansible projects, right? And you don't want your production network to be, to test it, to be the testing ground. Now, Molecule is a well-known testing tool for Ansible in the DevOps world. And the way it works, I'm going to explain more how it works in a little bit later, but the way it works is that it fires up virtual instances of whatever target system you're going to work on, and is going to run your Ansible projects against those instances. Now, the problem with it right now on the network automation world is that there's no out-of-the-box virtualization providers. Basically, you need to develop it yourself. But luckily, that's not that difficult to do. I'm going to show you a little bit later how to do it. Now, other challenges comes in the forms like there's no access to network devices. Well, no node access. It can be difficult to get access to network device virtual images, okay, because of licensing or accounts that you may need with that vendor in order to obtain it. Only a few vendors provide network device container images if you want to go with the container-based route. I strongly suggest that you check out the VRNet Labs project on that point. I highly recommend it. Most emulation and virtualization tools out there that we have for the network were focused on GUI, on the graphical user interface. But now they have been, evolving, and now we can have either SDKs or they have some really good REST APIs that we can leverage to access the resources in a programmatic way, the likes of GNS3, EVNG, CML2. There are also projects like Cisco iOS, which emulates network equipment, okay? And I'm actually using this one for the demo, for the mock demo. I'm going to talk more about this and how it works just before the execution of the demo. Okay, Molecule overview. So what is Molecule? Molecule is a CLI tool for testing your Ansible playbooks, roles, or collections. It brings up instances to execute your Ansible project against them and validates their end state. It provides a framework to manage the life cycle and the resources of that test, okay? So if you're going to use Docker, it provides the ways to fire up Docker instances in networks and destroy it, and at the end, cleaning up those resources. It's built with the concept of pipeline and scenarios, okay? Now, pipeline is the same kind of concept that you will normally see in CI tools like Travis, Jenkins, GitLab CI, or GitHub Actions. Pipelines are a set of steps that are concatenated between each other where you can actually execute some tasks, and they're going to give you a success or fail output And if it's successful, then it's going to fire up another stage of that pipeline. And if it's a failure, then it's going to stop, so you can take action on that. Okay. And the scenarios of molecule are based on configurational settings for your test. What I mean by that is, well, it's actually better to explain it with an example. Let's say that you have a multi-vendor network infrastructure, and your playbooks are the focus of your playbooks is to generate configuration for all of them. You can have a molecular scenario for each vendor, okay? So you can leverage the roles and the modules for each vendor, and test them in a separate way, okay? So it gives you that capability. Now, supports multiple virtualization providers. I already talked a little bit about Docker, but you can use Postman, you can use Vagrant. There are multiple virtualization providers out there. Now they are integrated. The molecule is in the form of plugins, so you need to install them in order to actually use them. But for us, in the network automation context, we're mainly going to use the delegated one. So we can define the creation and the destruction of these resources in our own way. Okay, so it gives you that capability. Now, where is it used? Molecule is can be used as a CLI tool. Is great for local development. So whenever you're developing your Ansible projects, you can test whatever you're doing with the CLI. So on your local environment is what is commonly used. It's commonly seen in the CI tools like Travis CI, GitLab, or Jenkins. Actually, in the documentation in Molecule, there are really good snippets of how to integrate Molecule with your CI pipelines. Now, what is a Molecule pipeline? In this example, in this slide, I'm talking about the Ansible checks and test setup of the pipeline. And I'm going to run the molecule test, which is basically going to fire the entire pipeline of a specific scenario. First, it's going to do some dependency resolution. Okay, this is normally on Galaxy. Most of the cases, this is going to be skipped. And there's a linting phase that calls external commands like Ansible lint or YAML lint to validate your playbooks that you're going to run for that test scenario. But this is really powerful in ways that if you have modules or plugins, Python plugins, and you can leverage tools like Flake8 or Black inside the linting phase to check those as well. There's a cleanup and destroy phase that is basically, going to clean up. If there are any previous instances that were created, it's going to destroy them, or any previous instances, it's going to destroy them. There is a syntax phase that is an Ansible syntax check. And then comes the create phase, which is going to call the virtualization provider to fire up these virtual instances. The prepare phase is going to prepare those instances. Or if you have some kind of external checks, like a database that you want to call inside your test, you can run the commands to set that up and verify that connection in the prepare phase. Then comes the test execution, validation, and cleanup. This is where the action is. The converge is when you run, is the phase where you run your Ansible playbooks against the virtual instances. The idempotence is basically going to rerun the project again, and it's going to check each task if it's going to be idempotent. If one of those are not an idempotent task, then it's going to fail. Then there is the verify phase, which is basically an Ansible set of playbooks that you can define to validate the end state of your environment. Or let's say that you're saving some information on an external data system, you can call that and verify that is what you expect. And then there's the normal cleanup and destroy phase. Now, molecular scenario structure. Now, molecular scenario structure. Molecule runs the pipeline steps on a per scenario basis. Each scenario must contain a molecule YAML file that instructs how molecule will behave on that specific scenario. Other playbooks may be defined to explicitly state the workflow of that stage. A good example is the demo. We have a create YAML, a destroy YAML, a prepare YAML, where I manually specify the tasks that are going to run on each phase. Molecule provides a default template for creating scenarios, the directory structure. This is like a cookie cutter template. You can run Molecule init, specify the name of the scenario that you want to run, and specify the driver if you want, like Docker, for example. When using drivers like Docker, you can specify the Docker file if you want Molecule to create the image for you first. Inventory and playbooks of the project can be linked, used in the Molecule tested scenario. This is especially useful if you have some variables that you want to use from your project itself, or merge with another variables that you have on your tested scenario. Okay, that's a really good overview about Molecule. Let's talk about the demo, so you can see it in action. Now, the demo is pretty simple. It's based on an Ansible project that is going to collect the interface data out of the Cisco iOS container, which is mocking a network device, basically an SSH server that I connect using, normal SSH connection, and it's going to run a show IP interface brief command to collect the data. And the raw data is then passed into TextFSM to give it like a structured format. And then I'm going to save that information in an Elasticsearch container. Okay, all this information, again, can be seen in the GitHub repository. Now, the scenario that I'm going to run is called mock. So there's the first thing that you are going to check there is the Molecule YAML file. There's a section for defining the platforms that I'm going to use. Router 01 is basically the mock device using the Cisco iOS, and I specify a command on how to run that container. I'm actually exposing and publishing the ports of that container, so even if I fire up the instances, I can reach them from my machine. And yeah, there's also a create and destroy playbooks that are based on the Docker driver, but are tweaked to change the connection type to network CLI. So basically, Molecule is going to fire them up as normal container images, but then it's going to connect to them instead of going through the Docker route. It's going to use the network CLI connection plugin, SSH, to gate the data. And to connect to the instance. And then there's a prepare playbook, which basically waits for Elasticsearch to complete the boot up process and have a health check there for the cluster. So it's demo time. This is the Ansible demo project repository. There's a README file that guides you through the overall steps and process that you will need to run in order to set it up. One thing that I want to highlight is that you need a Python virtual environment with these dependencies installed to successfully run the Ansible playbooks and the Molecule tests. Also, the scenario that we're going to run is called mock, and for that you need a Cisco iOS container that is going to function as your mock router. Here are some steps on how to do that. Now, the layout of the demo is like a standard Ansible project. You have your YAML lint files, Ansible lint files, with some rules inside of it. You have your playbooks folder with the playbooks that you would normally run against your network infrastructure, and your inventory folders with your inventory variables and information on how to connect to the devices. Okay. Now, the playbook that we're going to test is this one, which is by collecting data out of the interfaces using iOS command, running show IP interface brief, saving that information into the output variable using TextFSM, this template to be precise, to parse the data, interface, IP information, status, and have that structured data saved into an Elasticsearch database under the interface data index. Okay. Now, I normally have a verify YAML that is going to validate whatever changes my Ansible playbooks made. So in this case, the verify YAML is querying the Elasticsearch database for this interface, Fast Ethernet 3.1. And then it's asserting that that interface have these attributes set, which is IP, status, and so on. Okay. Now, the molecule scenario is going to be mock, and here's the molecule file. The first thing that I want to highlight is that the driver is set to delegated, meaning that I manually create that YAML and destroy that YAML files for those parts of the pipeline. And the lint phase is going to call YAML lint and Ansible lint to the playbooks that are inside the playbooks folder. On the platforms, I already explained it on a previous slide, but basically the router 01 is going to be the Cisco iOS container, and I'm publishing one of the ports so I can connect from my own terminal. The provision is set to be Ansible, and you will normally set here parameters for Ansible to be run with Molecule, like where you're going to get the inventory variables and parameters based on group bars and stuff like that. Now there's a section called playbooks, which is important to highlight here because I'm specifically stating that the converge phase and the verify phase are going to use the playbooks that I have on my playbooks folder. Okay, so I'm using my production-ish playbooks for this test scenario. Now, all of the other playbooks are inside the mock folder. So the create folder, the create YAML, is based on the Docker plugin, which creates the Docker networks, creates the molecule instances, and waits for them to be complete. Now, this part over here is hard-coded and has to be inside the created YAML for molecule to run successfully. So it's part of a blueprint when you run the molecule in it. But the trick here is that the connection is set to network CLI. So even if these are containers that are run, I'm not going to use the normal Docker connection for accessing these instances. I'm going to run the network CLI. So I'm going to do basically SSH. Okay. The destroy, something similar. I'm just destroying the instances, waiting for the deletion to be completed, and then deleting the Docker networks, and basically sending the molecule data back to as it was before. Once the devices are created, the network as I created the prepared YAML, waits for Elasticsearch to come up. Again, I explained a little bit before. But the Elasticsearch database is queried on the cluster health, and I have multiple retries here. Okay, so when it is ready to start receiving documents, for start indexing some documents, I go to the converge phase. Okay, so that's a lot of talk. Let's see it in action. So instead of going through the whole pipeline, I'm going to go through each significant step of the pipeline and interact with it, with the scenario, so you can see how interactive Molecule can be when you're developing your own Ansible projects. Okay, so normally the first thing that I would do is run Molecule lint, okay, which is basically just going to do YAML lint and Ansible lint against my playbooks. They are good. Basically, the mock collected mod data and the verify YAML are good, since I have, a good status code. But let's actually change it. Let's change the indentation here. Test it out. My ID is already, my Visual Studio Code is already stating that, hey, there's something wrong here. But let's run the lint and see what it says. Yeah. So it actually caught the syntax error and it highlighted it and also stated an error, a status code of 1. So if I run this in CI pipeline, this will just fail the task and it's going to be highlighted in the pipeline and I need to take some action on it. So that's pretty good. Let me just undo that. Okay, let's run the create phase. Now the create phase is going to run create and prepare. So create, again, is going to run the molecule created YAML. So it's creating the Docker network, creating the molecule instances, waiting for them to complete, and populating molecule files, basically. Then it's running the prepare phase, which is basically waiting for Elasticsearch to come up. It takes a while, normally. So here, that means I just 21 retries left. The Elasticsearch instance came up with a healthy cluster. We can actually see that. I have a code command for that. Yeah, so here it is. In this case, oh yeah, by the way, the Elasticsearch instance is exposing its ports as well, so I can access it from the terminal. And yeah, the status is green, so that's all good. I can actually SSH to the Cisco OS container. Okay, and the command that I'm going to get the data out of Stripe interface brief, and this is interface information that the container has. That's all good. Okay. I haven't run the converge phase, meaning that my playbook, my main playbook that I want to test, has not been executed, and I can actually test that. Here is a curl command for the Elasticsearch that is going to search on that index and just want the 7th interface. You can see that the index is not found and the status, the overall status is 404, so there's no document there. So all that is good, is what I expect it to be. Now let's actually run the converge. You can see that by default it's going to run the create and prepare, but it's going to skip it because the instance is already created and prepared. So all that's good. Right now it's running the playbook, so it's running the collecting more data. So I have this is the output from the Cisco OS raw output. Here I already parsed the information, and here I already sent all my interface data to Elasticsearch. Okay, so that means that my Elasticsearch instance should have data now, and here it is. I actually called interface the doc number 7, so it's the 7th document that was indexed, and it's in interface fast returner 3 with these attributes. Okay, all that's good. Now normally you will run the molecule idempotence check, which is basically doing a rerun of your Ansible playbooks and verifying that each task is idempotent. Great. Now let's run the molecule verify. Now the verify, if we remember correctly, the verify is going to call the verify.yaml playbook that I have here, and it's going to do a query, get interface elastic doc, and then it's going to do an assertion. So everything is good. Okay, but that's not fun if everything is green, right? So I'm just going to say that the admin status is called UPA. Let's run it again and see what happens. Okay, so we can see that the assertion actually gave an error, and we also have an std out, a standard status code error on number 2, which in a normal pipeline will fail and I have to take action on it. Okay, so all that is pretty good. Let me just fix it. And let's run an entire pipeline. Now this is going to run the entire pipeline process. And one of the first things that it's going to do, so it's going to do the lints, but it's also going to do the cleanup and destroy. So my previous containers and the Elasticsearch container that already had the index data are going to be gone, okay? And they're going to be recreated on this run. So, well, this is going to take some time. It's going to create, prepare them, run the playbooks, doing a dependency check, verification, and finally a destruction. And I know that this is going to work, so I'm just going to continue. Well, conclusions. Well, treating Ansible projects using a test-driven development approach will take more time, more development time. That's true. But your change management window, your managers, especially your operations teams, are going to thank it. Molecule might be overkill for a simple one-off use cases, but it will definitely be an asset for more complex scenarios, especially when you have integration with other systems, like a database or another API that you need to call, get data out of. So it is flexible enough to test each phase independently. I actually show you that demo that you can test different phases and play with that. Now, it consumes a lot of resources when performing the test, especially the CPU. Right now, I'm recording and running the molecule test, so my fans are actually like screaming, but just be mindful of that. And since the application is CLI based and returns, correct std out and stdr errors, it works well with CI pipeline tools. Here you can see some links and resources: the project, the Ansible community project, the molecule demo that I showed you, and other resources like Cisco iOS and VRNet Labs, which I strongly recommend that you take a look at. And with this, I finished the session, and I hope you enjoyed it. Thank you.